Hello and welcome to the first lesson of Chapter 6 on probability. Today we're going to learn about simulations, but first we're going to learn about some terms with probability. There's three methods for answering questions involving chance. We can look at observational probabilities. That's looking at data that's already occurred and trying to predict the future off of that. There's theoretical probabilities. And finally, there's simulated probabilities. Today, we're going to focus on figuring out how to simulate probabilities and how to predict the future based on that. Simulation, the imitation of chance behavior based on a model that accurately reflects the phenomena under considerations, is called a simulation. Now, there's a lot of simulations. You hear simulations used with military. There's a lot of computer simulations. Um, uh, there's simulating cars um, hitting other objects for car safety. There's a lot of simulations that are used in the real world. Whenever you do a simulation, make sure you understand what the problem is, and then you want to state the assumptions. The assumptions are usually that each act is independent. Then we want to assign digits to represent outcomes. And then after we do that, we simulate many repetitions, and then we state what conclusions we can get from that. All right, say a couple wants to have kids. They want to simulate as many possible outcomes as possible. We want to simulate the outcomes, see what the probability is of what they have, boy or girl. Now, we can simulate this with a die, saying we can roll one die, and 1 through 3 will mean that it's a boy, 4 through 6 will mean that it's a girl. So we can keep rolling a die many, many times and see what comes out. So if we did this, I'm just going to do this real quick. We're going to get male, male, female, female, male, female, 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 male, 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 female, male, 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 female, male, and male. So I just kept rolling the die, and whatever I got, if it was 1 through 3, I called it a boy or a male, and 4 through 6, I said it was female. So from this, we can look at the probability. If I said, what's the probability, the simulated probability, that the couple has exactly 2 males? Well, this one would be a check. No, this one would work. That one's too many, and this one would be there. So the simulated probability would be 3 out of 6, which is 1/2. So about half the time they would have exactly 2 males. Now, having 6 trials isn't really enough trials to get a good probability that's close to the theoretical probability. So the more trials we do, the better the probability we get. All right, use a simulation for finding the probability of getting a run of 3 consecutive heads when you flip a coin 10 times. Now we can flip a coin 10 times and see how many heads we get, and then do it another 10 times, and do it another head 10 times. But we could also do it with our calculator using random integers. To find our random integers, we hit Math. We go over to Probability. Random integer is number 5. We go from 1 to 2, and then we want 10 digits to come out of that. Now let's assign numbers. If it's 1, that's going to be a head. Number 2, that's going to be a tail. So when I hit enter, we want to see how many times that we'll get 3 consecutive heads, and then not 3 consecutive heads. So I'll hit enter here. There's We went 3 ones in a row. Oh, look, we got 3 ones, so that counts. Now if I hit enter again, I get 3 ones there, that counts. Now if I hit enter again, oh, I get 3 ones there, that's working. Hit it again, that worked. There's 3 heads, 3 ones. Hit it again. Oh, I actually did it twice. This one has it. And we can keep on going. I was hoping that one of these wouldn't have it. All right, this one doesn't have it. Now, I only did 6 trials, which isn't enough to really count for a good probability. But the simulated probability that you get 3 heads will be 5 out of 6. So there's a good chance you're going to get 3 heads in a row when you flip a coin 10 times. So if we want to run that 20 times, we can just keep on hitting enter until we get 20 events. Now, were these trials independent? Yes, independent is a big word in this chapter. We have to assume that each trial, each time you flip a coin, each time we hit enter, that those numbers don't depend on previous numbers. What are the probabilities that can be simulated with one die? Well, we could have 1, 2, 3, 4, 5, and 6. So we could do 1/6 probability. The probabilities could be 1/6, 2/6, which is 1/3, 3 out of 6, which is 1/2, 4 out of 6, which is 2/3, 5 out of 6, which is just 5/6, or 6/6, which is 1. Now another thing we can do is take out one number and say every time we roll a 6 it doesn't count. So we could simulate something that has a 1/5, 2/5, 3/5, and 4/5 probability also. So that would be 1/5, 2/5, 3/5, and 4/5, and 5/5 we already have here. We could also say if you roll a 5 or a 6 it doesn't count. So 1/4, 2/4, which we already have as a half, and 3/4 would also work. 4/4 is 1. Now if I scratch that off and say 4, 5, and 6 don't work, we have 1/3 and 2/3 already. So this is all of the probabilities that you can simulate using one die. It's a lot more than most people think. Most people would just do the first 6, but you can actually do these other ones if you just eliminate one number. All right. Joe Mauer in 2010 batted .327. His averages, he averaged about 4 at-bats a game. We want to simulate what happens in 30 games. So what we're going to do is we're going to say we're going to get random numbers from 1 to 1,000, and the numbers 1 through 327 are going to be considered hits, and we'll say out is from 328 to 1,000. So to simulate that, I'm going to do math, go over to random integer, number 5. I'm going to do 1 to 1,000, comma, we're going to do 4 things. So if I hit enter, let's count how many hits he gets. Looks like 1 hit. So I'm going to move this so we can see everything. 1 hit, I'll tell you that here. 327. That's going to be 0 hits. Bad day there for Joe Mauer. We have 1 hit. I'm going to do 2 in a row just so I don't have to go back. So here's a 1, 2, 3 hit day and a no hit day. A 1 hit day. One, 2, 3 hit day, or no, just 2 hits. 1, 327. So that's a 2-hit day. Just barely got in that second hit. Here it would be no hits. And 1, 2, so a no hit and a 2 hit. So here I have 10. In class we simulated this 30 times, but I don't want to put you through all of those. I think you understand hopefully you understand what we're doing. We're just hitting enter, and if it's between 1 and 327, we call it a hit. Otherwise, it's an out. So 3 times he got 0 hits, 3 times he got 1 hit, 3 times he got 2 hits, at 1 time he got 3 hits. So we could make a histogram out of that. It looks better if we have more data, but from this we could do 1, 2, 3. So this is 0 hits, 1 hit, 2 hits, and 3 hits. Our data would look something like this. All right. Now let's use a simulation to show how we can simulate orders for frozen yogurt. Frozen yogurt comes out 38% of the people choose chocolate, 42% choose vanilla, and 20% choose strawberry. If we randomly choose 10 people, what's going to be the distribution of yogurt flavors? So first thing we have to do is get the numbers in order. So numbers 1 through 38, those are going to be the chocolate people. I'll just put this next to them. So 39 through 80. Yep, 38 plus 42 is 80. Yep. That's going to be vanilla people. 81 through 100 is going to be strawberry people. So 38 people here, 42 people here, and 20 people here. So now what I'm going to do is I'm going to randomly choose 10 numbers between 1 and 100, and then I'm going to see how many people are in each category. So 1 through 38 is here, 39 through 80 is here, and then 81 through 100 is in this category. So let's clear this out. Random integers from 1 to 100. And we're going to pick 10 of them. Not 109, 10. All right, so if I go through, 37, 51, 49, 92, 40. Oh, that didn't work. Here, let's see if I can drag that down. Great, I have them all here. So we have 37, 51, 49, 92, 40, 18, 44, 99, 24, and 49. So this would be 3, 5, and 2. That was my first distribution. If I hit enter again, then we could drag these here. Nope. Drag them up here. And then drag this one here. We could do this by 8, 98, 32, 51, 41, 24, 11, 97, 23, and 16. So on that time, we had 6 people, 2, and 2. So we could continue doing this, and in class we did that all 7 times, and we filled up the chart, and then we were able to see all of the probabilities that we can get. All right, here's your homework for tonight. Good luck.